So in this video, we're going to take a look at some of the general ideas around how networking works within vSphere, how we get virtual machines connected to each other, how we connect them to the network, and how the host plays into all of this and how the host can communicate. So we'll talk more about host communication in the VMkernel adapters video, but here we'll take a look more at the virtual switches, the port groups. We'll talk about how to integrate VLANs into your vSphere environment kind of correctly, or at least the different approaches you can take. I guess you can decide what's correct. And then we'll take a look at a demo around the standard vSwitch, but we'll talk a little bit about the distributed vSwitch as well. So when it comes time to connect virtual machines either to each other or to an external network, we're going to be connecting them to a virtual switch. So every virtual machine is going to have its own MAC address, and we're going to provide layer 2 networking. I assume probably most of your virtual machines are going to run IP, but they actually don't need to. If you're running a network server, you could run IPX SPX. You get Ethernet connectivity via the virtual switch. That virtual switch hopefully has one or more uplinks associated with it, physical network cards associated with it that will actually connect you out to the network. But there's no network address translation, there's no routing, there's nothing that vSphere really does to that traffic. But I may need to separate some of my VMs from each other. I may need to separate some of my VMs from the physical network, and all of those things will require us potentially to build multiple virtual switches and or what's called port groups. So in the little diagram here, it shows the virtual machines being connected via virtual network card to the virtual switch. For the most part is true, but there's a port group association there, and that port group allows us both to bind to the switch, without specifically referring to a switch by number or something like that. And also we can override some of the switch behavior on a grouping basis. So when you look at the standard virtual switch, this provides us with a pretty basic layer 2 Ethernet switch. So it does support some of the things that you would expect from a switch, but it doesn't exactly work the way a switch typically would. So there's not much that we need to do. You can configure VLANs, and we'll talk about VLANs a little bit later. You can configure additional network interfaces to actually connect the vSwitch to something else. But if you have a vSwitch with virtual machines connected to it, they can talk to each other. Until we get some uplinks associated with that vSwitch, they're not going to be able to get out to a physical switch anywhere, right? And we can set up some teaming and load balancing and security options. We'll talk about all that as we go through this video. But yeah, basically you've got a pretty standard layer 2 switch that provides support for VLANs through the 802.1q protocol, not the Cisco proprietary protocol, the inter-switch link, I think they call it. But we do have the standard VLAN support. We also have standard teaming support in the form of something called 802.3 AD. And although there's other ways to do this as well, we'll talk some more about that later too. And we've got support for the Cisco Discovery Protocol. It does not actually support the spanning tree protocol, which is probably the number one thing you think of when you think of switches. But spanning tree protocol is required to avoid the creation of loops. vSphere's virtual switches never allow traffic to pass from one uplink to another uplink through the virtual switch. You can't uplink a bunch of physical switches together with a virtual switch in the middle. It just won't let you do that. So there's no option to introduce loops by introducing vSphere, so we don't need support for spanning tree. In fact, to make this work the best, we actually want spanning tree disabled on the ports that we're going to connect vSphere to. But we do want them to be set up as trunks. So in certain ways, we set them up the way we would allow switches to communicate with each other. And in other ways, we set them up the way we would have a host communicate to the switch. So a little bit unusual, but think of them very much as switches because they are switches. Now, VMware has in Enterprise Plus something called the distributed virtual switch rather than the standard virtual switch. And it does have some interesting capabilities that the standard virtual switch doesn't have. The primary one being that if you have many, many hosts, configuring the virtual switches in a compatible and consistent way across all those hosts is actually quite difficult. But for vMotion to work correctly, it's absolutely critical that you do that. Making changes to virtual switching with standard standalone single host associated virtual switches, relatively hard to do. When we get into the distributed virtual switch, then we just apply the configuration once. It's actually managed by vCenter, and it gets applied to the vSwitches associated with each host. Technically, there is actually a standard vSwitch that kind of hides behind this initially while it gets initialized, but basically takes over the functions of the normal vSwitching and can do things that the standard vSwitches just won't do. And in fact, one of the other things you can do using the same interface that this plugs into is use a non-VMware distributed virtual switch like the Cisco. There's actually a few different versions now of the Cisco that you can use for this, but the Nexus 1000 was a very popular concept. You can actually get that for Hyper-V and other products as well too, though. So basically, you can support more things connected to the distributed virtual switch. We haven't really talked about the limits, but there definitely are. I'll show you more of that in the demo. And has a bunch of capabilities like span ports and so on, and private VLANs that we don't get on the regular virtual switch. So you can actually do full inbound and outbound load balancing, whereas the regular virtual switch will only do outbound load balancing. We'll talk about this more in a little bit. You can also support auto deployment concept. In a large vSphere environment, we could have hosts that don't have permanent installations. So we actually boot them from the network. They receive an ESXi image and also receive a configuration from vCenter. So the distributed vSwitch is required to do that. You can support multicast snooping. You can support different kinds of filtering. For example, if you had virtual machines that were allowed to bridge traffic themselves, they could introduce routing loops, but the vSwitches themselves won't. If you want to ensure that that doesn't happen, or that someone is not trying to spoof the whole bridge protocol discovery process, you can actually use BPDU guard to suppress that type of traffic from being able to actually come out. And there's a few other things that we can do as well with it you don't get on the standard vSwitch. So overall, it is definitely more manageable, but you require Enterprise Plus to get it. So it's a pretty big investment to make, and not everyone's going to have this available to them. But if you do, this would definitely be the way to go. There's a lot that goes into, really supporting all this and so on. We're not really going to get into it in this series, but if we ever do an advanced series of this, then definitely all these Enterprise Plus capabilities are going to be the focus of that. So beyond the virtual switch, in order to actually associate a virtual machine to a virtual switch, we need what's called a port group. So at a minimum, you're going to have one port group for every virtual switch that you want to connect virtual machines to. You could actually have more than one port group connected to the same switch, and they could have different configurations. So some of the security options, the load balancing options, the teaming options, we could control those differently for one set of virtual machines compared to another. They could also have different VLAN tags. So that allows me to have a virtual switch configured in trunking mode with a reasonable number of uplinks, maybe 2, maybe 4, maybe 10, I don't know, maybe 100. I have to check the limits. I don't know if you can do 100. So when it comes time to do VLAN integration, there's quite a few options available to us. We could leave it completely up to the switch, but in that case, we're going to have to configure certain physical switch ports as being on specific VLANs, and then basically wherever I connect to those ports, then I'm going to end up on those VLANs. Now, this would be very difficult to support. In a large environment with lots of VLANs, it would be very difficult to provide enough, redundant and, enough capacity of the number of uplinks that I have to connect them into each VLAN physically. So what we're better to do is what's called virtual tagging, which is really kind of what a switch does when it carries someone else's traffic. So what we're going to do is we're going to have the virtual switch add the same sort of VLAN tags that it would if it was uplinked with another switch. And this is what we call trunking. Different vendors have different terms for it, but basically how switches communicate with each other. So using this trunking mode, which is very normal for interconnecting switches, but not using spanning tree like we were talking about, there is no possibility of introducing a routing loop or a switching loop. So we do not need spanning tree, and we can activate those ports faster if we disable the spanning tree protocols. So in Cisco, this is called port fast mode, which is basically what you would normally configure for a workstation or server, not for a switch. So a little bit unusual. There's other parts that come up when we talk about bonding and teaming and channels and things like that. And we'll discuss that a bit later on. So if we want, we can do what's called virtual switch tagging, or really vSphere controlled tagging. So I can create on a vSwitch, I can specify a VLAN tag, or on a vMkernel adapter, or on a port group, I can specify a VLAN tag. So I could have a virtual switch that maybe is on a specific VLAN or not on any VLAN or whatever. The port groups I can set really on the virtual switch. I'd be setting the default VLAN ID for the port groups and vMkernel adapters. I connect to it. So once I connect a port group or a vMkernel adapter to it, it's going to inherit the VLAN ID from the vSwitch, or I can override that and provide a different VLAN ID. So that way I can have a relatively small number of vSwitches with a relatively small number of uplinks, and I can still support a really very large number of VLANs. So I can have up to 4,094 VLANs on the system by doing it this way. That's quite a bit. If I use VLAN ID 4095 though, what I'm basically specifying is that we're going to participate in every VLAN, and we're going to leave it up to the guests, the actual virtual machines, to tag their own traffic. They have to include a tag on their traffic, at least if they're connected to a port group that's configured this way. They have to put a tag on their traffic. They need software to do it. And basically they can put any tag on that traffic. So not something you're always necessarily going to do, but could potentially be useful for you. But nonetheless, using VLANs is a good way to keep traffic isolated and separated from each other without having to use physical networking to do that and dedicating a whole bunch of, cards and cabling and, physical switch work to be able to do that. The biggest problem you're going to get here, though, is that a lot of Cisco shops particularly use the Cisco proprietary trunking protocol. I think I mentioned it as inter-switch link before, but I think that it's actually called the Cisco virtual trunking protocol as opposed to the 802.1q standard trunking protocol, which ideally is what they would use. If you use the distributed vSwitch and you replace it with the Cisco distributed vSwitch, then I guess you can run the Cisco proprietary protocols. So we'll take a look in the demo at configuring standard virtual switches. We're not going to do a demo of the distributed virtual switch. There's quite a lot of additional configuration you need to do to associate the network cards to it and so on, and it requires Enterprise Plus. So I'm logged into the web client, and you can see that I'm in the networking section, and you can see I've got port groups, I've got virtual switches, I've got physical NICs, VMkernel NICs, TCP/IP stacks, and firewalls. So the web client actually brings all these things together in a little bit of a better way than the desktop client actually did. But in this case, you can see I've actually gone ahead. This is being recorded after I already did the VMkernel adapters video. So you can see I've got a vSwitch 0, which is what I would have had created for me by default. And then I actually went and created, an additional vSwitch for the other one. You'll see in this case, I've got the option to say add standard virtual switch. If I was looking to do a distributed virtual switch, I need vCenter, I need Enterprise Plus, and I would do it through vCenter. Anyway, in this case, I'm going to say I want to add a standard virtual switch. And this is a little different, actually. When you do this through the Windows desktop client, you never really have the option to create a switch. What you do is you say add networking, as well as is this for virtual machines or is this for the system? And it builds a vSwitch for you, depending on what options you choose there. So you have to start with one of the other ones. Here I can actually just build one. So my vSwitch name, I don't know. I've never tried naming a vSwitch before. Typically in the desktop client, it's just going to name it for you, right? So in this case, I guess I can call it vSwitch 2. I'm curious what I can do here in terms of spaces and things like that, but no real reason to get creative. I can potentially set the MTU here, but maybe some of my virtual machines support this, maybe they don't. If you're trying to do jumbo frames for something like ISCAS or NFS, you should really be doing this probably in the VMkernel adapter. And then I can choose an uplink. In this case, I've only got the one uplink left from all the other vSwitches I've been doing and, the NIC teaming and such that I have. So it gives me just that one choice, but potentially I could have more if I had other uplinks available. And you see I've also got some security options here, and I have the ability to set whether I accept or reject promiscuous mode, which would be someone running a packet sniffer and is actually requested to receive all the traffic arriving to that vSwitch. Not normally what I would want, although I've had to do this before. I've had virtual appliances where the MAC addresses are hard-coded and they don't use the virtual machine's MAC addresses. So in that case, they don't get traffic unless you set them up this way. If I had to set them up, I would actually not really want to do that through here. What I would prefer to be doing is setting it on the port group rather than the vSwitch, right? And then just connect that virtual machine to that port group and not all the virtual machines connected to the vSwitch being able to do this. I can say whether they're allowed to change their MAC address or not. And I can also say whether they're allowed to do forged IP traffic, which again, probably I don't normally want. And if I had machines that I did want it, then what I should do is really create a port group saying just to allow it for them. So in this case, I've now created a vSwitch that has no port groups associated with it. It has an uplink, so it's connected to a network, and we don't know where that is. I mean, I use my VMkernel NIC 3, whatever network that's connected to is where I'm connected now. So what I really want to do though is add a port group to it. So I'm going to go and say, to just add port group. You can see there's the VM network and the management network port group, although the management network is really more of the VMkernel adapter and then the vMotion VMkernel adapter that I created. So I'm going to say add port group here, and then I'll attach it to whatever switch. I don't really like this interface. It's potentially easy to pick the wrong thing, right? And call this, security monitoring maybe. So maybe I have some virtual machine that I want to actually allow them to run in promiscuous mode and forge traffic and all kinds of things. So you know what, maybe I'll put that on my first vSwitch, my vSwitch 0 here. If there was VLAN tags, I could add a VLAN tag for it. I don't need to do that in this case, but I could override it. And actually, when I go into the port group after I've built it and go in and edit its settings, you'll see that you don't really get all the other options here, whereas you do in the desktop client have the option to override other things there as well, like the NIC teaming and the load balancing and all of that. So I'm not sure if there's a way to do that in the web client or not, but you know what, I'll show it to you in the desktop client. So I guess one of the few things you can still only do in the desktop client. So you can see that it switching back over there, I'm onto my host. I am connected to vCenter, but for this purpose, no real difference. Connected to my host, I'm in the configuration tab under networking. So you can see I have my virtual machine port group that I just created. You can see the vSwitch is represented a little differently. There's actually some graphics here. There is a little bit of a diagram that you can get out of the web client. But anyway, it's represented a little differently here. If I go to the properties of the vSwitch, then inside that, I can access the vSwitch's properties themselves. And, I may need to change some things in here, like the number of ports, for example, although this is more dynamic than it used to be. And the MTU and, all those security settings. And also the traffic shaping settings that we talked about in the slides too. They don't seem to show up in the web client. Although in the vCenter web client they do. I'm in the HTML5 host client, or at least I was. It doesn't. And then the appropriate NIC teaming options that I want to use. And we talked about all that stuff in the slides. So going back over though to my port group here, my security monitoring port group, so you can see my vSwitch does not allow promiscuous mode. So I'm going to go into the security monitoring port group and I'm going to say for them, I want to leave everything else the same that it was. I don't want to mess around with, your traffic shaping. I don't want to override your NIC teaming. I'll do everything else the switch is doing, except I want to allow virtual machines connected to that port group to do promiscuous mode. And maybe these other things too. Maybe those are the same that are on the switch, but just in case somebody changes the switch or something, I'll say, I want all those things to happen, but only for virtual machines connected to the security monitoring port group, not to, the VM network port group. I mean, yes, you could do all of this. There's other things that you could override as well. So we can see that I've got, VMNIC 0 and VMNIC 1 associated with the vSwitch. If I really wanted to, for some reason, well, maybe for monitoring, right? I want to make sure that all traffic arrives on like a specific NIC or something. Well, I guess that wouldn't really work, but anyway, I could even potentially override the failover order or something. I guess my scenario was not really accurate, but anyway, I could say specifically that I only want to monitor traffic on VMNIC 0 or only monitor traffic on VMNIC 1 or something. I mean, maybe possibly I could do something like that. So you could override those things at the port group level. In this case, I wouldn't necessarily do it, but when you get into the vMkernel adapters, then you may need to do it. And I mean, if I wanted to remove it or anything, I could potentially do that. It's relatively easy to go and to just remove the vSwitch. But remember, when you're operating here, you're really operating at the level of the vSwitch. So if you want to get access to the lower level parts, the actual port groups and the vMkernel adapters, then you can do that from here as well, and you can remove them from here. So in the web client, that's represented a little differently, but you can do that there. And if you go into add networking, it doesn't give you the option to add a vSwitch, but as you get through to the end of one of either of these choices, it will give you the option to say, I want to create a new vSwitch, or I want to use an existing one. Relatively the same experience, I guess, that we saw in the web client. So as we saw, there's not really that much to configuring vSwitches and port groups. We'll talk more about vMkernel adapters later. The main thing to understand is what your VLAN integration strategy is going to be, and to make sure that your physical switches have the right configuration to support interfacing with ESXi through the virtual switches. But in the next video, we're going to take a look at teaming and load balancing